which is an extraordinary number. If you think of the Kennedy School faculty with about more or less 200 individuals, he pulled far beyond his weight in order to do that. Most of those papers were single-handed efforts, which is really an extraordinary accomplishment. Topics he covered in those papers include patents, the banking industry, competition and intellectual property, the Federal Trade Commission, capital investment, the pharmaceutical industry, financial mergers, and chances are, if you're thinking of another topic, he wrote on that one too. So it's really a great pleasure for us to be able to welcome Mike back for this talk and learn from his 50 years of experience. Welcome.
Thank you very much, Scott. Actually, my title, I don't know how I got it, is a bit of a misnomer. 50 years. Well, actually, I thought I had said 60 years, but then I did the calculation and realized it was only 59 years that I've been working formally on this problem. It all started back 59 years ago when I took a course with John Lintner at the Harvard Business School and wrote a term paper, Capital Budgeting for Research and Development. And then shortly after that, when I got my MBA, I embarked on a 5-year research project at the business school that was called the Weapons Acquisition Research Project, in which we did case studies of 12 advanced weapon systems developments and 8, as I recall, commercial developments. And that's when my formal analysis of uncertainty really began. This first chart is from the first book we wrote on the weapons acquisition process, in which we realized that there are different kinds of uncertainty in research and development, and there's a very well established spending pattern. Your R&D is sort of a bell-shaped curve. Starts low, peaks as you're about to launch production, and then your production costs go up. And the uncertainties decline at different rates. Is this thing technically feasible? That gets determined quite early in the in the process. Normally, there are some exceptions like the atomic bomb development. They didn't really know until they blew off a prototype in the desert. But normally, technical feasibility declines quite rapidly. And if it doesn't, you don't go forward. How well the thing is going to perform, technical performance, takes that declines at a somewhat slower rate. How long it's going to take you to develop it, that declines even more slowly. And then production costs, really you don't know for sure until you get into production and determine what your learning curve is going to be. Well, I also worked out this curve for civilian products, and again you've got this bell-shaped curve in terms of spending on research and development over time. Typical commercial project takes about 4 years, some much longer, of course. Again, technical feasibility declines very rapidly in the early stages. If you don't have that, you don't go forward. How well the product will perform, that takes longer to find out. How much is the product going to cost? Still slower rate of decline. And really big uncertainty, market acceptance, that takes quite a long time to find out. Even when you go onto the market at year 4, you really don't know whether the thing's going to crash and burn or whether it will be well accepted by consumers. Same thing is sort of true with drug development, which I've done a lot of research. There's a well-ordered sequence of stages under the current Food and Drug Administration regulations. You start with many years of preclinical discovery, theorizing and trying every bottle on the shelf, in effect. And then when you think you've got something, you have a period of animal tests. Is this thing going to work in animals? Does it kill the animals? And if they come out okay, a very low rate of expenditure, at year 0, the way I've calibrated this, at year 0, the actual research and development program starts. And that is typically divided into 3 formalized phases, phases 1, 2, and 3. Phase 1 is you try the thing out for the first time in human beings. First of all, is it